Hello everyone, today we will learn about Chapter 4 Assembly Language. Okay, what is assembly language? Each personal computer has a microprocessor that manages the computer arithmetical, logical, and control activities. Each family of processor has its own set of instructions for handling various operations, such as getting input from keyboard, displaying information on screen, and perform various other jobs. A processor understands only machine language instructions which are string of 1 and 0. It looks like binary. However, machine language is too obscure and complete for using in software development, so the low-level assembly language is designed for a specific family of processors that represent various instructions in symbolic code and more understandable form. This is a sample of language. You can see on your left high level language is C language and it compile in a binary for the machine language. Okay, 0101. Advantage of assembly language. How program interface with operating system, processor and BIOS. How program access external device. Other advantage of using assembly language require less memory and execution time. It allows hardware-specific complex job in easy way. It is suitable for time-critical job. Okay, assembly language programmer must therefore understand the computer architecture. Okay, programmer rarely use assembly language for application or even system program. It provides expressive power and consensus that great as eases the program task. The advantage of using assembly language for development time. Writing code in assembly language take much longer than writing in high-level language. Okay. Reliability and security. It is easy to make error in assembly code. The assembler is not checking if the calling convention and register safe convention are obeyed. Okay, what is compiler? Compiler is a program that convert another program from source language or programming language to the machine language. Executable code. The machine code generated by the source code language processor such as assembler compiler. Okay. This is software is a form that can be run in computer. We also have instruction set. The collection of all possible instructions for particular computer. There is a collection of machine language instruction that particular processor understand. Basic features of PC hardware. The main internal hardware of PC consists of processor, memory, and register. Register are processor components that hold data and address. To execute a program, the system copies it from the external device into internal memory. The processor executes the program instruction. The fundamental unit of computer storage is a bit. It could be on, 1, or off, 0. A group of 9 rated bits make a byte, out of which 8 bits are used for data, and the last one is used for parity. According to rule of parity, the number of bits that are on 1 in each byte should always be odd. So, the parity bit is used to make a number of bits in byte add. If the parity is even, the system assumes that there had been a parity error, which might have been caused due to hardware fault or electric disturbance. Okay, this is an example of binary arithmetic. We have learned how to calculate a binary in chapter 3. Okay, here we can see two complement notation. To subtract one value from another, convert the number being subtracted to two complement format and add the number. For example, number 53. So our binary is 00110101. For number 42, 001010 and 10. Okay, we reverse the bit of 42. So it become 0 will become 1, 1 will become 0. So when we reverse 42, it become 11010101. We add 1. Okay, 53 minus 42. So we equal 11. So we put in binary 000010 and 10. Addressing data in memory. The process through which the processor control the execution of instruction is referred as a fetch, decode, execute cycle or execution cycle. It consists of three continuous steps: fetching the instruction from memory, decoding or identifying the instruction, execute the instruction. The processor may access not one or more bytes of memory at a time. Let us consider the hexadecimal number 0725H for decimal. This number will require 2 bytes of memory. The higher order byte or more significant byte is 07 and the lower order byte is 25. You must remember, after 10, we will start with A for the hexadecimal. Okay, the processor store data in reverse byte sequence. Low order byte is stored in low memory address and high order byte in high memory address. So, if the processor bring the value 0725H from register to memory, it will transfer 25 first to the lower memory address and 07 to next memory address. Okay, when processor get the number data from memory to register, it again reverse the byte. There are two kinds of memory address: absolute address, a direct reference of specific location; segment address or offset, starting address of memory segment with the offset value. Basic syntax. An assembly program can be divided into three sections. Data section. The data section is used for declaring initialized data or constant. This data does not change at runtime. You can declare various constant value, file name, or buffer size. Okay, in this section, we put section.data. BSS section. BSS section is used for declaring variable. The syntax for declaring BSS section is section.bss. The text section. The text section is used for keeping the actual code. This section must begin with the declaration global start, which tells the kernel where the program execute begin. For example, section.text, global start and start. Assembly language statement. Assembly language statements are one of four types: instruction, directive, macro definition, and comment. A comment statement is simply a statement that consists entirely of a comment. Instruction. Executable instruction or instruction. Instruction, the bulk of the non-comment statement in assembly language program are symbolic representation of machine language instruction. Almost invariably, there is one-to-one relationship between an assembly language instruction and machine instruction. The assembler resolve any symbolic reference and translate the assembly language instruction into binary string that comprise machine instruction. Okay. Each instruction consists of operation code or opcode. Each executable instruction generate one machine language instruction. Assembly directive or pseudo-op. Some they call as a pseudo instruction. Tell the assembler about the various aspects of assembly process. These are non-executable and do not generate machine language. Instead, directives are instructions to assembler to perform specific action during assembly process. For example, define constant, initialize area of memory, design area of memory for data storage, allow a reference to other program. Macros. Macros are basically text substitution mechanism. A macro definition is similar to subroutine in several ways. A subroutine is a section of a program that's written once and can be used multiple times by calling subroutine from any point in the program. When a program is compiled or assembled, the subroutine is loaded only once. A call to the subroutine transfer control to the subroutine and return instruction in the subroutine return. Similarly, a macro definition is a section of code that the programmer writes once and then can use many times. Okay, this example assembly language statement, they enter one statement per line. Okay, we have label, operand, and command. Okay, the field and square bracket are optional. Basic instruction has two parts. The first one is the name instruction or the mnemonic, which is to be executed, and the second are operand or the parameter of the command. Following are some examples of a typically assembled language statement. In count, increment memory variable count. Okay. Memory segment. Segment a special area in the memory that is defined a program, contain the code, data, and stack. The segment position in the memory is not fixed and can be determined by the programmer. Three main segments for the programming process. First, code segment contain the machine instruction that are to execute. Typically, the first executable instruction is at the start of the segment and the operating system link to the location to begin program execution. Number two, data segment contain program defined data, constant, and work area. Stack segment contains any data or address that program need to save temporarily or for use by your own called subroutine.